All right. Hello, everyone. Thank you for joining. Before we get started, I want to introduce myself. I'm Florencia Paredes. I'm the head of product here at Citrine. I've been at Citrine for almost 7 years. I have a background in material science from Cornell and Stanford, background in strategy consulting, and polymer engineering. And with me today, we have my colleague Ryan Luttrell. He's a materials informatics engineer here at Citrine with a master's in material science and engineering from the University of Washington. And he has 3 years of experience in product development in consumer electronics and batteries. So welcome, everyone. Today I want to go through how using the Citrine platform, we have been able to reduce cost and increase margins for the ingredients and additive manufacturing industries. And before we get started, I want to do first a quick intro to Citrine Informatics, then talk about some of the challenges that we've seen with our current customers in ingredients and additive manufacturing, and ways that Citrine can help. Finally, I'm going to go through a specific case study with one of our customers, and then at the end, we're going to do a demo that Ryan is going to share for us. So Citrine Informatics is a software company founded back in 2013. We provide AI software to accelerate product development, optimize production, and increase sales. The Citrine platform provides chemists, scientists, and product developers the tools to leverage AI for their projects without the need to code or to be an expert data scientist. Our system was purpose-built for the physical world of product development. It can handle small data sets to make predictions and can integrate expert knowledge like engineering rules of thumb and analytical equations for improved performance. In addition to our software, we also have a team of experienced professionals who guide our customers on their AI journey to success. So with the Citrine platform, our customers can make better, more efficient products faster. When tweaking an ingredient or designing a new formulation of a product, as scientists and engineers, we know we can have hundreds to thousands of degrees of freedom, if not more. Evaluating all of those dimensions systematically is not practical. Sometimes tests are tens to hundreds of thousands of dollars, or it can take weeks to months to run. We can't test everything in the lab. This is where AI can help. With the Citrine platform, scientists and developers can explore billions of possible formulations and recipes before choosing the next best experiment to run in the lab. We've been showing results for our customers for over 10 years. Our customers range from some of the top companies in the specialty chemicals space, adhesives and sealants, and personal care industries, and include companies developing plastic additives, personal care ingredients, and powder fillers. And we've seen that while the products our customers make are varied, there are common challenges. One, understanding the impact of an ingredient or additive on the performance of your customer's final product is critical. Adapting quickly to supply chain issues is now a requirement in this market, and it continues to be an imperative to do all of this while keeping costs low. I want to pause here and get your input. Do these challenges resonate with you? Are you seeing these challenges at your company? And what are you doing today to address them? So please let us know in the chat here on Zoom, write in what you think. While those come up, I'm going to switch gears and walk through a case study. So Dorfner has been using the Citrine platform for years. They are a 130-year-old mining business in Germany, and they have two main problems that they've been dealing with before Citrine. One, they needed to reduce the time to create new formulations and find new uses for their additives. And two, they needed to maintain consistency in those formulations, even when their additives varied significantly in shape and size. So using the Citrine platform, they developed a tailor-made ingredient especially designed to fit into their end products. They found a 20% savings in production costs and saw a reduction in their CO2 processing footprint. Not only this, they also observed an increase in the quality of end products using this new additive. In addition to this, Dorfner also developed other new products to bring to market. They expanded their offerings in their current market and also opened new offerings outside of Europe. And they did this in part by shortening their new product development cycles by 84%. Imagining shortening your development cycles by more than half. How valuable would that be to your business? And not only were they able to decrease their costs, they were also able to maintain high quality and consistency of their products. You don't have to hear the story from me. Dorfner themselves have shared how they are leveraging AI. And on April of last year, so about a year ago now, they shared how Dorfner has raised revenue by 30% using the Citrine platform. This really shows how leveraging AI tools can have massive benefits for the ingredients and additives industry. So how did they do it? In the next couple of slides, I'll walk you through our tried and true simple workflow to optimize and find new recipes. And it starts with data. On CP, you can drag and drop test data onto the platform as an Excel file. Then you can create AI models without knowing how to code. And we do this by providing a default model created automatically from your data and then providing experts with an easy-to-use tool to improve the model by adding any analytical equations there might have or defining relative material processing and property interactions. Next, you can define your search space. This is where you can make sure that the candidate formulations the system will suggest are feasible both from a practical and business perspective. And lastly, you can set target properties, generate a ranked list of experiments that then you can take to the lab. And because the platform not only predicts properties, but also estimates the uncertainty of predictions, you will know whether the experiment is a safe bet or more exploratory. So you can then make good strategic decisions on what to take to the lab. This is what drives the reduction in the number of experiments you need and reduces those development cycles. Once you've created and tested the suggested ingredient or additive, the test results can then be added back onto the platform and the AI retrained to make predictions more accurate. In this way, you have a learning loop that gets closer and closer to your performance targets. So what does that mean from your point of view? Let's say that you need to respond to your customer's request and provide a new ingredient that will solve their problems. With the Citrine platform, you can leverage data from previous projects with your customers, their properties of interest, what they're interested in improving, and your detailed information of how you've made your ingredients. With a few clicks, you can create an automatically configured AI model that can predict performance on these properties that your customer cares about. And then you can create a search space that contains your ingredients and potentially the ingredients of your rivals so that the system can suggest the best ingredients for the final formulation. And finally, you can generate candidate formulations and color code them by ingredient. The results are a list of new AI-suggested formulation recipes. And on the Citrine platform, you can quickly see which of your ingredients would be the best for this type of formulation. So with the Citrine platform, you can show not only that your ingredient can produce superior performance, but also how certain you are that it will hit target requirements before you go to the lab. So now I want us to move on to the demo portion of our webinar. So I'm going to hand things over to Ryan here to go through that. Ryan?
Great. Thank you for the introduction and information, Florencia. So let's dive into the platform, and I'll show you how you can optimize your ingredients with AI. So let's imagine that I am a surfactant manufacturer. We want to compare a new plant-based surfactant to our competitors and show how they can perform in terms of syneresis and IRBS in paint formulations. We will use some data from previous customers from testing paint formulations, and then go into the data set that we have loaded. And here we have the main page of the platform. As Florency was going over, we have a generalized workflow of four main sections that we will be talking about today. So initially, we will upload our data onto the platform. We then will create a training set based off of this data to visualize some of the direct correlations between different formulations and ingredient properties in our data. We can then use this training set to train the AI model. The platform will generate a default AI model directly from the data. And then we can edit and revise this model to become as accurate as needed. After refining our AI model, we then create a search space which allows us to apply our domain knowledge to limit certain ingredients, as well as to try out different types of ingredients for different what-if scenarios. Finally, after validating our search space and AI model, we then can generate our candidates. We'll set objectives and constraints, such as selected final properties, such as IRBS, and then the platform will score these properties and the different formulations, and then generate graphs of them that we can use to compare. So first off, I'll be starting off in the data manager. Here we can look at the data sets that we've uploaded and investigate the different properties and ingredients that we have. I'll be selecting our APO paints formulation data set. You can also filter the data in your data set to look into different properties or ingredients that your customers might be interested in. Additionally, we can also perform a quick analysis on our data. Here I've saved a couple of different graphs from this analysis. So we can showcase an easy correlation between the initial viscosity and the 24-hour viscosity, as well as some more information about how ingredients are impacting certain outputs. So we can see here there's a direct correlation between surfactant share and initial viscosity, as well as binder share and the 24-hour viscosity. We also have multiple ways of looking at our data. So we have distribution plots that can map the overall data set and showcase the trends in the data, as well as if there are any outliers that we should maybe be concerned about. In the data manager section, we upload our data in the forms of a CSV or Excel file. As mentioned, this is a no-code platform, so it's meant to be as easy as possible for the user. So next, let's move on to the training set area. After uploading the data set, we can then ingest it into the training set. And we can see all of our final formulations on the left-hand side here, as well as more graphs that we can look on the right hand. I'll select one of our formulations. And then we can look into the specific properties and ingredients in this specific formulation. So here we have the measured properties. These are the final predicted properties. And then the material history. This material history is a great opportunity to really understand the different ingredients and processes that go into your final formulation. So I can zoom in here and we can see how on the left-hand side, we have all of our required ingredients. So water, acrylics, defoamers, etc. We can see different properties that are included for them, such as particle size. And then in the middle here, we have different processes such as letdown and grinding, as well as any intermediary ingredients, such as the APO surfactant A. In particular, for this APO surfactant, we've included a SMILE string in the molecular structure property. Now, this is very important for the platform because the platform is able to generate 127 different data points for this ingredient. The platform then chooses which of these data points to use in the AI model. Some of these properties include atom count, bond count, polarizability, and enable a more precise model to be generated. Additionally, on the right-hand side, we finally have the final mixing for the final formulation. And so we have the final properties as listed above for this specific formulation. This material history is another chance for you to really visualize your formulations and your ingredients and see how they map all together and connect as a whole. So now I'll be returning to our main project page. And this leads us into the AI model section. Now, AI can be scary and can sound confusing at times, but our platform is meant to make this accessible and easy to everyone. You do not need to be a data scientist to understand this platform, and it's meant to help speed up your testing and your experimentation of various ingredients. So right here, we have that training data is ingested at the top of the model. We then have different nodes and features that then lead into the final ML model. So as I mentioned earlier, we're talking about smile string. We have a molecular structure node that incorporates that smile string. Here we have 8 selected properties from the 127 different data points that I was mentioning. We can see atom count, bond count, and atomic polarizability. This atomic polarizability in particular is really important, and we'll discuss that later, but that's used in the calculation of IRBS. We can also add in custom formulas. So this is a great way to apply some of our own domain knowledge into the platform and really amplify the AI's performance and power. So here we're comparing the surfactant amounts to thickener amount to calculate a surfactant fraction. Now, we're using this because we're interested in the surfactant impact on the predicted outputs. However, as you explore different avenues of research or different ingredients that you want to tweak for your formulations, you can create different types of custom formulas to explore those avenues. And finally, we have our ML models at the bottom. So IRBS and one-week syneresis are particularly properties that we're interested in today, but we also have viscosities and gloss properties that are being outputted as well. After editing our model and refining it, we are then able to train and validate the AI model and then evaluate the performance of the model. We have multiple ways of calculating and measuring performance of the model. One such is R-squared value, which is a great standardization way. I'll then be showcasing how specifically our model performs related to IRBS. One key factor on this page is the feature importances. So this means that these features, when changed, will have a larger impact on the predicted output of IRBS. So right here we have at number 2 is surfactant fraction, and at number 4 is atomic polarizability. Now this polarizability is calculated due to the smile string that we incorporated it in our materials history from the data set. That means that the data that we put into the platform is having an impact down the road in the predicted outputs. Additionally, we have our surfactant fraction. Now, this is number 2, so that means as we change our surfactant in our exploration on this platform, that'll have a large impact on the predicted output of IRBS. So we really want to make sure we're careful when we're changing our surfactant between our competitors and our own, and make sure that we're aware of how that might impact other properties as well. Additionally, down below, we have our feature impact plots. Now, this is a great opportunity to then delve deeper into these feature importances. These plots specifically show the direction and magnitude of these feature impacts, and is a great way to investigate further which of these properties are having different types of impacts on your predicted output. I can then go back to the main page. After refining the AI model, we can then move on to the search space. Now, this is a great opportunity to then limit the ingredients that you use in your formulations and that showcasing to your customers. So here, we're particularly interested in surfactants for this project. So down here, we have the different surfactants we're using. So we're making sure that we're including surfactants, but we're also making sure to limit the number of surfactants to one and only one per formulation. And we're only using 0.2% to 4% of our formulation is going to be a surfactant. We can then go into the ingredients tab to look at the various individual surfactants that we're interested in. So in particular, for today at least, we are not going to include any APO surfactants. These are toxic ingredients to humans and the environment, and we want to showcase the power of our plant-based surfactants. These non-APO surfactants are competitors' surfactants that we want to compare our own ingredients against, and then the plant-based surfactants are listed over here. Now, once you've determined which ingredients you want to include in your final formulations and how many and what percent in your formulations, there are a couple other areas that you can tweak as well. So we have different ratios you can add in, as well as other parameters is where you can edit the processing conditions that you want to make sure are followed by the AI model. After validating the search space with respect to the AI model, you can then proceed to the candidates page. Here we set the objectives constraints. So we want to minimize the 1 week syneresis and the IRBS. After doing so, the platform will then generate a list of candidates, which are scored on how well they actually meet those objectives. Now, one powerful aspect of this page is our ability to filter out different candidates. So here we can see that we've got a few different colors on our plot for the candidates in respect to IRBS and 1 week syneresis. So I can showcase our competitors' formulation that are using their competitor's surfactant, which is a non-APO surfactant. And then I can highlight our own plant-based surfactants in blue. Here we can see that they have a very similar distribution and have similar values in terms of IRBS and 1 week syneresis. We can go to our customers and tell them that our plant-based surfactant performs technically as well as the non-APO surfactants from our competitors, but has the additional bonus of being a sustainable product. Additionally, in our list, we can also click into our different candidates to look into the individual ingredients and processes that are involved in each formulation. So for this specific formulation, I can see the predicted output for 1 week syneresis and IRBS, and I can see how likely it is to meet that predicted property. Additionally, I can look into this specific ingredients that are used in this formulation. So I can see that this specific formulation is actually using one of our Plantacare 818, one of the plant-based surfactants that my company has developed. We then also have the various parameters for the processing conditions. Now, these candidates are meant to be recipes that are generated by the platform that you can then print out and take into your laboratory to immediately start testing. This is meant to speed up and create a more efficient laboratory testing environment for you and your company. After refining the AI model and generating candidates, we also have an exploration tab in our AI model that you can use. Here is another virtual laboratory environment that you can use to test out different ingredients in your already made formulations. So I can select any of the materials or formulations that I've made and upload it in the data set. I can then see what ingredients and processing conditions were used for this formulation. So I can see if this one was using APO surfactant A. I can then easily add in one of my plant-based surfactants, and then make sure that it's the same amount. And I can then delete the APO surfactant. After running the prediction, I can see how its predicted outputs compare to the initial outputs of the initial formulation. All the purple is the new predicted outputs, and the gray is the old. I can see how it's minimizing IRBS compared to the APO surfactant. So this is a quick and easy way to showcase a simple switch of one ingredient and how that might impact certain predicted outputs. Now, I hope you've seen how easy and accessible this platform is to use. From uploading your data in the form of a CSV to Excel file, we then proceed with the training set, where you can visualize your data and look into the different materials and ingredients that are being used. We then train our AI model off of this training set, and then with a default model is being generated immediately after training. You can then edit the AI model to fit your domain needs, and then we can proceed to the search space. Here we can use our domain expertise to limit certain ingredients and provide some restrictions on our search space. Then finally, we proceed to the candidates page. Here we set our objectives and constraints, how we really want to help our customers, and we can showcase to our customers how our ingredients impact their formulations in comparison to our competitors' ingredients. And now I'll throw it back to you, Florencia, to wrap us up.
All right. Thank you, Ryan. All right, so we just did the demo. And to recap, the Citrine Platform is helping the ingredients and additives manufacturing industry already, specifically working on accelerating work and meeting complex business and technical product targets. Formulators across multinational enterprises have been using our platform for over 10 years and seeing success. We talked about an example with a customer that who's seeing a lot of success. And really, with our team of chemistry nerds, data gurus, and change managers, we can help you roll out AI at scale. So please get in touch with us to find out more, and if you have any questions. And now I want to open it up, excuse me, to our Q&A portion of the call. So please enter your questions on Zoom. If not, feel free to email us at info@citrine.io. And if you're looking for additional resources, please visit citrine.io. We have many case studies and white papers and all sorts of material in there. And you can also find the video that I highlighted today about Dorfner in there as well. So as we wait for the questions to come in, thank you all for attending, and please reach out if there's anything we can help with.